Find the second derivative y double prime, or d squared y dx squared, for the function y equals the square root of cosine of x, then evaluate y double prime of 0. So y here is the square root of an expression cosine of x. Before we take the derivative, let's first rewrite this square root as a fractional exponent. It's cosine of x to the first power and then second root, or 1/2 power. Our first derivative, y prime, or dy dx, we'll start with the power rule. We'll bring the power down, 1/2, leave the inside alone, cosine of x. Subtract 1 from the power, so that'll be 1/2 minus, I will call it 2/2. Multiply by the derivative of the inside to complete the chain rule. Derivative of cosine is negative sine. Let's collect our constants together. The negative and the 1/2 will be in the front. We have cosine x to the 1 minus 2, negative 1/2 power, and then we have the sine x. Now the negative exponent means move to the denominator, and that means it'll move it down with the 2. The rest is in the numerator, so I have a negative 1 and a sine x remaining in the numerator. Negative sine x over 2 times cosine x to the 1/2, which means I have a quotient of functions now, and therefore our second derivative will make use of the quotient rule. Our second derivative, y double prime, or d squared y dx squared, will be the derivative of the numerator. The derivative of sine is cosine, the negative comes along, times the denominator left alone, minus the numerator left alone, times the derivative of the denominator. We'll start with the power rule, bring down the power, leave the inside alone, subtract 1 from the power, I will call that 2/2, and then multiply by the derivative of the inside to complete the chain rule. And all of this is divided by the denominator squared. Now for the first term in the numerator, I'm going to collect together the constants. I have a negative and a 2. That'll give us a negative 2. I have a cosine of x here that's to the first power, and I have a cosine of x here that's to the 1/2 power. We can combine those by adding the exponents. 1 plus 1/2, 2/2 plus 1/2 is 3/2. So that'll give us a cosine of x to the 3/2 power. For the second term in the numerator, I have 1, 2, 3 negatives all multiplying each other. That will give us a negative. And then I have a 2 and a 1/2 multiplying each other. Well, 2 times 1/2 is 2/2, or the 2's can cancel, and that's just going to give us a 1 with the 3 negatives, which means we'll have a negative 1. I have a sine x and another sine x. Multiply those, and that's sine squared of x. And then we have the cosine of x to the 1 minus 2, negative 1/2 power, all over. The denominator, we can square each of those individually. 2 squared is a 4, and cosine of x to the 1/2 to the 2. You multiply the exponents 1/2 times 2, which is 2/2, or just 1. Cosine of x to the first power. So my second derivative, y double prime, or d squared y dx squared, will be, I'll leave the first term alone, negative 2 cosine of x to the 3/2 power. The second term, I'm going to rewrite moving this to the denominator to make it positive 1/2 power. So I'll have minus sine squared x over cosine of x to the positive 1/2 power, and then the entire thing is over 4 cosine x. Since I have a fraction in the numerator, I'm going to need to combine the two terms over a common denominator in the numerator. I'm going to need to have this over that same denominator. So that'll be my next step. So I'm going to take that first term and I'm going to multiply it by a cosine of x to the 1/2 over itself, a form of 1, so that I can produce the common denominator, and then this is combined with this other second term fraction that I'm going to leave alone. And the entire thing is still over the denominator of 4 cosine of x. For this first term fraction, all this is multiplying, and therefore I will have a -2, but then these cosine terms, I can add those exponents. Like base, add the exponents. 3/2 plus 1/2, which is 4/2 or 2. So I have a -2 cosine squared of x minus a sine squared of x all over a cosine of x to the 1/2 and then the entire thing over 4 cosine x. That 4 cosine x, being that it's in the denominator and the numerator is a fraction, I'm going to put that over 1, so it's itself a fraction, and now I can reciprocate it and multiply it with the numerator. So y double prime, or d squared y dx squared, will be, in the numerator I have -2 cosine squared x minus sine squared x. We may be able to get the trig Pythagorean identity of sine squared and cosine squared with that. But right now I'm going to reciprocate the denominator fraction and multiply with the numerator fraction. Multiplying the numerators, anything times 1 is the same thing. And multiplying the denominators, I'm going to have a 4, and then I have a cosine to the 1/2 power here, and I have a cosine to the 1 power, which this 1 power here can be thought of as 2/2 power, and you can add the exponents. That's going to give us a cosine of x to the 3/2 power. Now we're going to be able to produce the Pythagorean trig identity in the numerator if I separate the cosine squared x's. We have -2 of them. I can separate into a -1 and a -1. Now the whole reason I separated it that way is we will then match the coefficients of one of them with the sine squared term. They're both -1. And that'll be over a cosine of x to 3/2 times that 4. To have the Pythagorean trig identity happen in the numerator, we're going to want to factor out a -1 first, so then it becomes cosine squared x plus sine squared x, and then it's over 4 cosine of x to 3/2 power. So our second derivative will now be a negative cosine squared x minus 1 all over 4 times cosine of x to the 3/2 power. The negative can be factored and put to the front. That's an optional way to write this, in which case it'll be cos squared x plus 1. And there is our second derivative of y double prime, or d squared y dx squared, in its simplified form. The next thing to do is evaluate y double prime of 0, which means to plug a 0 in for each of the x's. So I will have a negative of, now remember that cosine squared means to evaluate the cosine and then square it. And down the denominator we'll have 4 times the cosine of 0, which we'll evaluate first and then raise it to 3/2. So we have the negative of, the cosine of 0 is a 1, so 1 squared plus 1 over 4 times, and then the cosine of 0 again is a 1, to be 3/2 power. So we have a negative 1 squared is 1, so 1 plus 1 over 4 times 1 to the 3/2 means the square root of 1, which is 1, and then cube it. So we have a negative 1 plus 1 is a 2, and then 4 times 1 cubed. 1 cubed is 1 times 4 is a 4. And we can now reduce this by a factor of 2, and we end up with negative 1/2.